Hello everybody, thank you for watching. This is our 7.11 empirical formula video. In this video, you'll learn about what is an empirical formula and how to use the steps to find the empirical formula for a specific compound. In order to talk about empirical formula, we quickly need to recap on percent composition. If you remember, the formula for percent composition is the mass of an element divided by the molar mass times 100. That gives you the percentage of each element in the compound. Now let's define empirical formula. So an empirical formula is the simplest ratio of elements in a chemical formula. And a quick example is if we have a formula that looks like this, H4O6, and an empirical formula is the simplest ratio of the elements, we know that we can take this formula and we can actually turn it into H2O3. So each of these elements have been divided by a specific number 2 in order to get the simplest ratio of these elements. This simplest ratio is called the empirical formula. Take a moment now to look at these 4 example problems and find their empirical formulas. In our first example, each of these elements have been divided by 6 in order to get our empirical formula of just CH. For their second example, you can see that each of these elements have been divided by 2 in order to get this empirical formula. For this example, each of these elements have been divided by 6. And then for our last example, you can't really turn this into any more of a simple form, so this actually is the empirical formula. There is a specific way to calculate for our empirical formula from our percent composition. And one thing I want you to remember is this rhyme to help you out. This rhyme is actually the different steps that you need in order to find your empirical formula from a percent composition. The first thing is you want to remember percent to mass. Then you want to change your mass to mole. Then divide by small. And then, lastly, multiply till whole. Lastly, another thing to remember is when we're calculating our empirical formula from a percent composition, we know that all percentages of an element in a compound always add up to 100. Therefore, if we can assume that we always have a 100-gram sample of each element, then we can actually just use the weight of each element and it's going to be the same as the actual percentage. And I'll show you what that actually means. Let's look at a couple example problems now of how to calculate for empirical formula using our steps and our percent compositions. So cisplastin is a compound that was once used to treat tumors. Use the percent composition of each element in the compound to calculate the empirical formula. So you can see right now we have percentages of everything that's in cisplastin. We have platinum, nitrogen, hydrogen, and chlorine. Our first step in finding our empirical formula is changing our percent to mass. And this is where, if you assume that we always have 100 gram of each sample, you can just take away the percentage sign and turn it into a gram sign. Therefore, you did not the first step, which is percent to mass. The second step is mass to mole. So in order to convert each of these grams into mole, you need to have their molar mass. So what I want you to do is look on the periodic table and convert each of these into moles. When you do that, you can see platinum has a molar mass of 195.08, nitrogen 14.007, hydrogen 1.008, and then lastly, chlorine, 35.453 grams. When we do that, we know that grams are going to cancel, and we're going to get our answer in moles. Once we change mass to mole, we have to do step number 3, which is divide by small. So you're going to look at each of these numbers and figure out which one is the smallest moles. Here, you can see that 0.333 is smaller than any of these other numbers. Therefore, you're going to divide each of these by that smaller number. So, each of these numbers are going to be divided by 0.33 moles. When you do that, you're going to get answers that look like this. 1, 2, 6, 2. Lastly, we want to multiply till whole. And what I mean by that is you want to make sure that these numbers are all whole numbers. All right, in this case, we can see that they are all whole numbers, so we don't really need to do anything for that step. Now, what do these numbers even mean? If you take a look at cisplastin, again, we know it's made up of platinum, nitrogen, hydrogen, and chlorine. Each of these numbers are actually the subscripts in the empirical formula. So we can take these numbers and just add them next to each of these elements. Right now, this compound looks like something that's very unfamiliar to you guys. Therefore, you can change it, if you wish to do so, into something that's more familiar. You can see we have platinum, ammonium, and chlorine. And this is actually the empirical formula of cisplastin. You can see that it's the empirical formula because you can't reduce any of these substrates anymore. Let's take a look at another example. A mystery white powder prepared from lime has many medical and industrial uses. One use that is used for is for root canal filling. What is the name of this compound? Use the percent composition below to find the empirical formula. So go ahead and use the first step, which is percent to mass, then mass to mole. You can see that grams are going to cancel. Our answers are going to be in moles. We want to take a look at whichever number is the smallest and divide by small. And lastly, we want to multiply till whole. So you can see right now I got an answer of 1.98 for hydrogen. Because this is so close to a whole number, you can actually just round it to 2. Lastly, you can see we all have whole numbers now, so we don't need to multiply anything. So these are actually going to be the subscripts for each of these elements. It looks something that's unfamiliar to us right now. You can actually change this to calcium OH parentheses with the 2 on the outside, and the name of this compound is calcium hydroxide. Let's try our last example. Ethanol is made up of carbon, hydrogen, and oxygen. If we have a 11.51 gram sample of ethanol, it's found to contain 6 grams of carbon, 1.51 grams of hydrogen. Find the empirical formula of ethanol. Right now we're not really sure how much oxygen we have. So we need to calculate how much we have. So we have a total of 11.51 grams. We can subtract that by carbon and hydrogen, and that gives us the grams of oxygen. Then you want to change mass to mole. And in this case, we already have everything in grams, so we just need the molar mass to change it to moles. Divide by small. We have this as our smallest number. We're going to divide each of them. We're going to get subscripts that look like this. Because they're so close to something that is a whole number, you can actually just change them to whole numbers. Lastly, multiply till whole. In this case, we all have whole numbers. Therefore, you can see that ethanol is made up of C2H6O. If you wanted to change that to something that's familiar to you, we know that 1 just means that there's an invisible 1 there. You don't need to actually add it. Go ahead and try this problem and come back to see if you got your correct empirical formula. And that concludes our video for today. Thank you for watching.